Hello everyone. Our next topic in integration chapter is integrants resolvable into partial fractions. Okay, so now we'll have a numerator and denominator, and in the denominator there will be a linear equation, okay, in a factorable form. Okay, we will get the factors of any equation, right? So we'll get it in the form of 1 by x minus a into x minus b, where a b values will be different. Then we can write it as capital A by x minus a plus capital B by x minus b. Here we'll find the value of a and b, and then we'll integrate this function. Okay, similarly it may have a linear equation in the numerator also. Okay, px plus q, here the degree of x is 1, so it can be a linear equation in the numerator. Then also the case will be same, x a by x minus a plus b by x minus b. And it may also have the factor in the square form, so it is twice, right? This function is twice and this is once, so we can write it as a by x minus a plus b by x minus a whole square plus c by x minus b. So this function should write for one time, and next time we should write it as square. Similarly, it can have a quadratic equation in the numerator. So the function can be resolved into the partial fraction same as in the above case. Okay. And when there is a linear function in the denominator and a quadratic function in the denominator, okay, whenever there's a quadratic function we should write bx plus c by the quadratic function. Okay, with this function cannot be factorized further, means we cannot get the factors of this denominator. Okay, right, the quadratic equation, then we can use this formula. Okay, and this is the linear equation. For that it is the same case, only a by x minus a, plus for the quadratic we'll write bx plus c. Okay, so in the numerator it can have a quadratic function or it can have only one in the numerator. Okay, for both the cases the partial fraction is c. We'll solve some of the problems, you will understand how to use this. So our first question is, evaluate integral sin x cos x by cos square x plus 3 cos x plus 2 into dx. So here we'll consider the value of cos x as t. Okay, put cos x is equals to t. If we differentiate cos on both sides, so it is minus sin x dx is equals to dt. Shifting minus there, so it is sin x dx is equal to minus dt. Substitute all these values in a function, we'll get integral t into minus dt by t square plus 3t plus 2. Now the denominator is a quadratic function, so we can take the factors of it, right? So here 2 ones are 2, 2 and 1 are the factors, so it is t square plus 2t plus t plus 2. So taking t common, so it is t plus 2, and here writing the same factors, so the common factor will be plus 1. So t plus 1 is one factor and another factor is t plus 2. So this can be written as integral minus t by t plus 1 into t plus 2 dt. Now this function can be resolved using partial fractions, so we'll consider minus t by t plus 1 into t plus 2 can be written as a by t plus 1 plus b by t plus 2. Taking LCM, so it is minus t by t plus 1 into t plus 2 is equals to a into it is t plus 2 plus b into t plus 1 by t plus 1 into t plus 2. Cancelling out the denominators on both sides, will be left with minus t is equals to a into t plus 2 plus b into t plus 1. So now we can put the value of t as minus 1. Okay, if we put here minus 1, so what will happen, the value of b will become 0, right? Minus 1 plus 1 is 0, so it is minus of minus 1 is equals to a into minus 1 plus 2, and b becomes 0 here, so you'll get 1 is equal to a, right? So this will, the value of a is equal to 1. Now similarly we can put t is equal to minus 2, so it is minus of minus 2 is equals to a will become 0 now, plus b into minus 2 plus 1, so it is 2 is equal to, here it will be minus b, so this can be written as b is equal to minus 2. We have to take this as 1 and this as 2. Okay, substitute in equation 1 the values of a and b. Substitute a and b values in equation 1, so we'll get minus t by t plus 1 into t plus 2 is equal to, the value of a is 1 by t plus 1 minus 2 by t plus 2. Now we should integrate on both sides, so we'll get integral of t minus t by t plus 1 into t plus 2 dt is equal to integral of 1 by t plus 1 dt minus 2 will take outside, integral of 1 by t plus 2 dt. So now integral of 1 by x, right? Integral of 1 by x dx is equals to log mod x plus c, right? So this can be written as log mod t plus 1 minus 2 log mod t plus 2 plus c. So now we can write it as log mod t plus 1 minus this 2 can be written as power, right? So it is log mod t plus 2 square plus c. Now this can be written as log a minus log b, right? So log a minus log b, log a minus log b is equal to log a by b. So this can be written as log mod t plus 1 by t plus 2 whole square, right? A by b will go. Now we will replace the value of t, right? T we have substituted cos x, so it is log mod cos x plus 1 by cos x plus 2 square mod plus c will be the answer. So the second question is evaluate integral 7x minus 4 by x minus 1 whole square into x plus 2 dx. So here in the denominator our function is already in the form of factors, right? So we can resolve into partial fraction. So we'll consider 7x minus 4 by x minus 1 whole square into x plus 2, which can be written as this function is the twice, so we can write a by x minus 1 plus b by x minus 1 whole square plus c by x plus 2. Consider this equation as 1. Okay, now take the LCM, so it is 7x minus 4 by x minus 1 whole square into x plus 2 is equals to a into, here we are having x minus 1 as a single factor, so we need one more, so it is x into x minus 1 plus into x plus 2. Okay, plus b into, we have this factor, we need x plus 2 plus c into, we need x minus 1 whole square for the c term, by x minus 1 whole square into x plus 2. We can cancel out the both denominators, so it is 7x minus 4 is equals to a into x minus 1 into x plus 2 plus b into x plus 2 plus c into x minus 1 whole square. Now we can substitute the values of, put x is equals to 1, so what will happen, this a will become 0, right? 1 minus 1 0, and this c will become 0, so we'll get the value of b. So it is 7 into 1 minus 4 is equals to, a will become 0 plus b into 1 plus 2 plus c into, it will become 0. So 7 minus 4 is 3, 3 is equal to 3b, which will get b is equal to 1. Similarly, we can make this term 0 again, and this b also 0 again by putting x is equals to minus 2. So it is 7 into minus 2 minus 4 is equals to a will become 0 plus b will become 0 and c will be minus 2 minus 1 square. So it is minus 14 minus 4 is equals to c into minus 3 whole square. So we'll get minus 18 is equal to 9c, which gives us the value c is equals to minus 18 by 9. So it is minus 2, right? 9 is a 9 2. So we'll get c is equals to minus 2. Now, in order to get the value of a, we should equate the coefficient of x square on both sides. Equate coefficient of x square on both sides. Okay, so in this equation, okay, in equation 2, so here we are not having any x square coefficient, so it will be 0. This side is equal to, here we'll get the value of a and here plus c. Okay, so we'll get the coefficients of x square is a plus c is equal to 0. Okay, so putting the value of c here, we'll get a minus 2 is equals to 0. So we'll get a is equals to plus 2. Now substitute all these values in equation 1. Substitute a, b, c values in 1. So we'll get in 7x minus 4 by x minus 1 square into x plus 2 is equals to, the value of a is 2 by x minus 1. The value of b is 1, so it is plus 1 by x minus 1 whole square. And the value of c is minus 2, so it is minus 2 by x plus 2. Now integrate on both sides. So we'll get integral 7x minus 4 by x minus 1 whole square into x plus 2 dx is equals to 2 outside, integral 1 by x minus 1 dx plus integral 1 by x minus 1 square dx minus 2 integral 1 by x plus 2 dx. So here we'll use two formulas, which is 1 by x, right? Integral of 1 by x, which is equal to log mod x, and here it is integral of 1 by x square, which is equals to minus 1 by x. Okay, so this can be written as 2 log mod x minus 1 minus 1 by x. Okay, integral of 1 by x square is minus 1 by x minus 2 into log mod x plus 2 plus c is our answer.